The red dust swirled in thin spirals around the Perseverance rover's wheels as it navigated the ancient riverbed of Jezero Crater. Sol 1-1247 of the mission had begun like any other: systematic drilling, sample collection, and the methodical documentation that had characterized NASA's most ambitious Mars exploration to date. The rover's Moxie oxygen generator hummed quietly in the background, converting the thin carbon dioxide atmosphere into precious oxygen for future human missions. The Martian morning cast long shadows across the desolate landscape, where silence reigned supreme, except for the occasional whisper of wind across the barren terrain. Dr. Elena Vasquez monitored the data stream from her workstation at NASA's Jet Propulsion Laboratory, 45 million miles away. The 14-minute communication delay meant that every command sent to Perseverance was a carefully calculated decision, each movement planned hours in advance. The rover had been investigating a particularly intriguing geological formation, layers of sedimentary rock that suggested ancient water activity, precisely the kind of environment where microbial life might have once flourished. These formations represented billions of years of Martian history, compressed into readable layers that told the story of a world that had once been dramatically different from the frozen desert it had become. The mission's objectives had evolved significantly since Perseverance's landing in February 2021. Initially focused on searching for signs of ancient microbial life, the rover's discoveries had consistently exceeded expectations. Previous samples had revealed complex organic compounds, mineral formations that required liquid water to form, and geological evidence of a warmer, wetter Mars that might have harbored life for hundreds of millions of years. Each new discovery added pieces to the puzzle of Martian evolution and increased the tantalizing possibility that life had once thrived on humanity's neighboring world. The morning's drilling operation targeted a sample designated as crater floor fractured rough. The drill's percussive action penetrated the Martian surface with precision, extracting a cylindrical core of rock that would eventually return to Earth aboard the Mars sample return mission planned for the early 2030s. The drilling process itself was a marvel of engineering, designed to operate in the extreme conditions of Mars, temperatures that could plummet to -80 degrees Celsius, an atmosphere less than 1% the density of Earth's, and radiation levels that would be lethal to unprotected human life. As the drill withdrew, Perseverance's cameras automatically documented the fresh hole and surrounding terrain. The cache cam, specifically designed to photograph samples before they were sealed in collection tubes, captured high-resolution images of the extracted material. The rover's sophisticated imaging system included multiple cameras capable of microscopic detail, 3D reconstruction, and spectral analysis that could identify mineral compositions from visual data alone. It was in reviewing these routine images that Elena first noticed the anomaly. Embedded in the freshly exposed rock face was something that defied immediate explanation, a metallic gleam that caught the pale Martian sunlight. The object appeared deliberately geometric, its edges too precise for natural formation. Unlike the random crystalline structures common in Martian geology, this artifact displayed purposeful design elements that suggested intelligent construction. Elena enhanced the image resolution, adjusting contrast and brightness to reveal details that made her pulse quicken and her scientific skepticism war with growing excitement. The artifact measured approximately 12 centimeters in length and appeared to be composed of an unknown metallic alloy. Its surface showed intricate patterns, not the random textures of geological processes, but purposeful designs that suggested intelligent construction. The patterns were reminiscent of circuit designs or mathematical formulae, with connecting lines and geometric shapes that formed complex networks across the artifact's surface. Most remarkably, the object exhibited no signs of the oxidation that should have occurred during millions of years of exposure to Mars's iron-rich environment, which had given the planet its characteristic red coloration. Elena immediately initiated emergency protocols, securing the data and alerting the mission's principal investigators. The discovery protocols for potentially artificial objects had been established during mission planning, though no one had seriously expected to invoke them. Within hours, a crisis team assembled virtually, connecting experts from JPL, NASA Goddard, the European Space Agency, the Japan Aerospace Exploration Agency, and leading universities worldwide. The secure communication channels buzzed with activity as experts from diverse fields, geology, archaeology, astrobiology, material science, and even xenoarchaeology, converged to analyze the unprecedented discovery. The implications were staggering. If confirmed as artificial, This would represent the first evidence of extraterrestrial intelligence ever discovered. The scientific community had long debated the protocols for such a discovery, but the theoretical had suddenly become reality. The artifact represented potential proof that humanity was not alone in the universe, that intelligence had evolved elsewhere and had once visited the worlds of our own solar system. Dr. James Chen, Perseverance's project scientist, coordinated the investigation with methodical precision. The rover's sophisticated instrument suite was redirected to analyze the artifact with unprecedented detail. Every available sensor was brought to bear on the mysterious object, from simple visual cameras to advanced spectrometers capable of determining atomic composition. The pixel spectrometer, originally designed to search for biosignatures in Martian rocks, revealed an elemental composition unlike anything in NASA's extensive databases, isotope ratios, that suggested origins outside our solar system. The spectrographic analysis revealed elements that existed on Earth, but in combinations and ratios that defied conventional understanding. The artifact contained traces of elements that, according to current stellar nucleosynthesis models, should not exist in the proportions detected. Some isotopes appeared to be artificial, created through nuclear processes that implied advanced technology capable of manipulating matter at the atomic level. The SuperCam laser spectrometer confirmed the presence of materials with properties that seemed to violate known metallurgy principles, including a crystalline structure that exhibited quantum properties at macroscopic scales. As news of the discovery spread through classified channels, the team faced an extraordinary decision. Protocols existed for this scenario, theoretical frameworks developed by SETI researchers and astrobiologists over decades of speculation about first contact. The discovery required immediate but careful analysis, balancing scientific rigor with the profound implications for human understanding of our place in the universe. The scientific method demanded skepticism and verification, but the evidence was becoming increasingly difficult to explain through conventional means. The rover's robotic arm, equipped with precision tools originally designed for geological sampling, carefully extracted the artifact from its geological prison. The process required extreme delicacy. The artifact was clearly ancient and potentially fragile, despite its apparent resistance to weathering. Detailed photography revealed surface markings that resembled no known writing system, yet conveyed an unmistakable sense of intentional communication. The patterns suggested mathematical relationships, possibly representing fundamental constants of physics, a universal language that any technological civilization might recognize. The mathematical patterns were particularly intriguing to Dr. Sarah Kim, the mission's lead mathematician and astrobiologist. The symbols appeared to represent prime numbers, mathematical constants like pi and the golden ratio, and what looked like star charts showing stellar positions. If these interpretations were correct, the artifact's creators had chosen to communicate using the universal language of mathematics and astronomy, concepts that any intelligent species would necessarily discover in their development of technology and space travel. Spectroscopic analysis revealed that the artifact's composition included elements in their pure form, arranged in crystalline structures that required advanced manufacturing techniques. The precision exceeded current human capabilities by several orders of magnitude, suggesting a technological sophistication that implied a mature civilization with mastery over materials science far beyond human achievement. The manufacturing tolerances were measured in angstroms, approaching the scale of individual atoms, indicating construction techniques that humanity had only begun to conceptualize in theoretical physics papers. Carbon dating of the surrounding rock layers indicated the artifact had been buried for approximately 3.2 million years, placing its deposition during the Pliocene epoch on Earth, when early hominids were just beginning to use stone tools. The dating was confirmed through multiple independent methods, including analysis of cosmic ray exposure, radiometric decay of surrounding minerals, and stratigraphic correlation with known geological markers. The convergence of these dating methods provided strong evidence for the artifact's extreme age. Dr. Sarah Kim proposed a revolutionary hypothesis that sent shockwaves through the scientific community. The artifact might represent evidence of ancient extraterrestrial visitors who had explored Mars during its more hospitable past. Geological evidence suggested that Mars had possessed a thicker atmosphere and liquid water billions of years ago, conditions that might have attracted interstellar explorers. The timing of the artifact's deposition coincided with a period when Mars still retained significant water reserves and a more Earth-like climate. The team conducted extensive analysis to eliminate alternative explanations, following the scientific principle that extraordinary claims require extraordinary evidence. Could the artifact be debris from human space missions? Impossible. The isotopic signatures were wrong, the burial depth indicated extreme age, and no human mission had ever reached the specific location where the artifact was discovered. Could it represent an unknown natural phenomenon? The geometric precision, mathematical symbolism, and material composition argued strongly against geological formation. Every conventional explanation was systematically eliminated through rigorous analysis. As investigation continued, additional discoveries emerged that transformed the scope of the finding. Ground-penetrating radar revealed similar metallic signatures buried throughout Jezero crater, suggesting not a single artifact but evidence of sustained presence. The radar imager for Mars's subsurface experiment, WIME-FAX, detected at least 17 additional objects buried at various depths across a 5-kilometer radius. The pattern of distribution implied purposeful placement, possibly marking specific geological or geographical features that held significance for the ancient visitors. The discovery prompted an immediate reassessment of data from previous Mars missions. Archive analysis revealed that similar anomalies had been detected but dismissed as instrumental errors or unusual geological formations. The Mars Global Surveyor, Mars Odyssey, and Mars Reconnaissance Orbiter had all recorded metallic signatures that, in light of the Perseverance discovery, appeared to represent additional artifact sites. The realization that evidence had been hiding in plain sight for decades added urgency to the investigation. The artifact's internal structure, revealed through high-resolution tomography using Perseverance's advanced imaging systems, contained microscopic chambers filled with exotic matter. These chambers appeared to be data storage devices, utilizing quantum-scale engineering principles that human science was only beginning to understand. The chambers were arranged in fractal patterns that maximized information density while maintaining structural integrity, a design philosophy that suggested both advanced mathematics and practical engineering experience. The discovery suggested that the artifact might contain information, possibly records of the civilization that created it. The quantum storage chambers exhibited properties consistent with crystalline memory systems that could theoretically store vast amounts of data in molecular-scale structures. If the artifact was indeed a data repository, it might contain historical records, scientific knowledge, or cultural information from an advanced extraterrestrial civilization. Dr. Chen authorized the use of Perseverance's most sensitive analytical tools to probe the artifact's deeper mysteries. The rover's MALDI mass spectrometer, normally used to analyze rock samples for organic compounds, detected complex molecules trapped within the metallic matrix. These compounds bore no resemblance to Earth biochemistry, containing amino acid analogues and protein-like structures based on silicon-carbon hybrid chemistry rather than the purely carbon-based chemistry of terrestrial life. The organic compounds were arranged in patterns suggesting information encoding, possibly representing the biochemical signatures of the artifact's creators. The molecular arrangements followed mathematical sequences similar to those found in the artifact's surface markings, reinforcing the hypothesis that multiple encoding systems had been employed to ensure information preservation across geological timescales. The redundancy suggested that the artifact's creators understood the challenges of long-term information storage and had designed their message to survive millions of years of environmental exposure. The implications extended far beyond Mars. If extraterrestrial visitors had explored our solar system millions of years ago, they might have left similar evidence on other worlds. The discovery prompted immediate revision of ongoing missions to Jupiter's moons Europa and Enceladus, where subsurface oceans might harbor not only microbial life but archaeological evidence of ancient exploration. The Cassini mission data was reanalyzed for possible artificial signatures, while planning for the Europa Clipper mission incorporated new search parameters for non-biological anomalies. International cooperation intensified as the magnitude of the discovery became apparent. The European Space Agency's ExoMars mission was redirected to investigate similar geological formations identified through orbital reconnaissance. China's Tianwen-1 rover received new instructions to search for metallic anomalies using its ground-penetrating radar, while India's Mars Orbiter mission was tasked with conducting global surveys for additional artifact sites. The discovery had united humanity's spacefaring nations in a common quest for answers, transcending political boundaries in the face of cosmic significance. Analysis of the artifact's quantum storage chambers revealed tantalizing glimpses of information that challenged human understanding of physics and engineering. Mathematical constants appeared consistently, but expressed in number systems that suggested different evolutionary paths toward mathematical understanding. Star charts showed stellar positions from millions of years ago, confirmed through computer models of stellar motion and galactic rotation. The astronomical data provided independent verification of the artifact's age while demonstrating the creator's sophisticated understanding of celestial mechanics. The star charts contained particular significance for Dr. Elena Vasquez, who had taken on stellar cartography analysis in addition to her primary role. The mapped constellations showed stellar positions as they would have appeared from a location approximately 47 light-years from Earth, in the direction of the constellation TRAPPIST. The TRAPPIST system was already known to contain multiple potentially habitable planets, making it a prime candidate for the artifact creator's origin point. The precision of the astronomical data suggested observation capabilities that exceeded current human technology by several generations. The discovery's impact on human civilization was immediate and profound. Religious leaders grappled with theological implications while philosophers debated humanity's significance in a universe that had clearly hosted intelligent life long before our species evolved. The Vatican issued statements acknowledging the discovery's compatibility with Catholic theology, while Islamic scholars found parallels in Quranic verses about life throughout the cosmos. Buddhist and Hindu traditions, with their concepts of infinite worlds and cycles of existence, adapted more easily to the revelation of ancient extraterrestrial visitors. Scientists experienced both excitement and humility, recognizing that human technology represented merely one point on a vast spectrum of possible development. The artifact demonstrated capabilities that humanity might not achieve for centuries, if ever. The materials science alone represented advances that would revolutionize human technology if the principles could be understood and replicated. The discovery forced a fundamental reassessment of human technological progress and our assumptions about the uniqueness of terrestrial intelligence. Dr. Vasquez continued her vigil, monitoring every byte of data transmitted from the red planet across the vast interplanetary distance. Each new analysis revealed additional layers of complexity, suggesting that the artifact represented technology far more sophisticated than initial assessment indicated. The creators had possessed not only advanced materials science but understanding of physics principles that human science had yet to discover. Quantum mechanics, relativity, and other fundamental forces appeared to be unified in the artifact's construction in ways that exceeded human theoretical understanding. The artifact's presence on Mars raised fundamental questions about the nature of intelligence in the universe. Had these ancient visitors been biological entities like humans or artificial intelligences exploring on behalf of their creators? The scale of their apparent capabilities suggested civilization-level engineering projects that dwarfed human technological achievements. Their technology implied mastery over matter and energy that approached the theoretical limits of what physics allowed, suggesting either extremely long technological development or fundamentally different approaches to understanding natural laws. As analysis continued, patterns emerged that suggested the artifact was not unique, but part of a larger network. Similar discoveries began emerging from archived data from previous Mars missions. Objects that had been dismissed as unusual geological formations now revealed under enhanced analysis to show signs of artificial origin. The Mars exploration rover's Spirit and Opportunity had photographed anomalous objects that, when re-examined with new understanding, exhibited characteristics consistent with artificial construction. The ancient visitors had left abundant evidence hidden in plain sight for decades. The discovery fundamentally altered humanity's understanding of our cosmic heritage. Mars had hosted visitors from another star system when Earth was dominated by early hominids, suggesting that interstellar travel and exploration were not theoretical possibilities but established realities. The universe contained civilizations with capabilities that exceeded human imagination, and they had once walked the same worlds that humanity now explored with robotic surrogates. The implications for human future development were staggering. If interstellar travel was possible, if civilizations could persist for millions of years, then humanity's cosmic destiny might be far grander than previously imagined. The artifact's quantum storage systems continued to yield information as analysis techniques improved. Language patterns emerged from the molecular data, suggesting not just mathematical and scientific knowledge but cultural and historical records. The visitors had left a comprehensive archive of their civilization, possibly intending it as a message for any future intelligence that might discover their presence. The archive appeared to contain star maps, technological blueprints, philosophical treatises, and what might be historical accounts of their exploration of the galaxy. Dr. Chen prepared the mission's most significant report, documenting evidence that would reshape human understanding of our place in the cosmos. The report underwent unprecedented review by experts across multiple disciplines, governments, and international organizations.
The implications required careful consideration, not just for scientific accuracy, but for the potential impact on human society. The knowledge that humanity was not alone, that intelligence had visited our solar system in the ancient past, represented a fundamental shift in human self-perception. The ancient visitors had left their mark on Mars, a testament to intelligence, curiosity, and exploration that transcended species and stellar systems. Their artifacts remained as monuments to the enduring drive to explore, understand, and leave traces for those who would follow. The discovery suggested that exploration and the search for knowledge were universal characteristics of intelligence, driving civilizations across the galaxy to venture beyond their homeworlds in search of understanding and contact with other minds. The red planet had revealed its greatest secret, hidden for millions of years beneath layers of dust and time. Mars was not merely a dead world waiting for human colonization, it was an archaeological site containing evidence of humanity's cosmic predecessors, visitors from the stars who had once gazed upon the same sun that now illuminated their rediscovered artifacts. The discovery marked the beginning of a new era in human understanding, one in which Earth and humanity were part of a vast community of intelligence that spanned the galaxy and persisted across geological ages. As humanity prepared for its own expansion into the solar system and eventually to other stars, the ancient visitors' legacy provided both inspiration and guidance. They had demonstrated that intelligence could survive across cosmic timescales, that exploration and discovery were worthwhile pursuits that could leave lasting monuments to consciousness and curiosity. Their artifacts on Mars stood as proof that the universe was not empty and lifeless, but filled with minds seeking understanding and connection across the vast distances between the stars.